Yeah, hello everyone. So we'll be starting with our next segment, which is going through this Collab notebook. We'll show how to train a model, fine-tune a model, train a language model, and deploy it as an app. Yeah, so in order to all these notebooks are accessible on our GitHub page. I'll just share the link as well. Yeah, so one easy way to go to these notebooks is to just search on Google IndicWav2Vec AI for Bharat, and it will lead you to our web page. From there, you can go to the code repository. But I'll share this link here as well. Yeah, so this is our homepage of the repository, and you'll find all the documentation regarding data, training, and deployment all here. So, for example, in the tutorials, you'll find multiple sections. One is on pre-training that discusses about data preparation, manifest creation, training procedure, and code. Then we have fine-tuning, same data preparation and fine-tuning procedure and code. And similarly for language models. We also have a section on deployment and model export. I guess that's not updated as of now. Some sections are still not updated. But for this demo, what we'll do is we'll go inside this workshop 2022 folder, and here we'll find a bunch of files. So these are the files which will help us in our current notebook. So first we'll open the notebook. In the notebooks, you'll find IndicWav2Vec_workshop_2022.ipynb. I'll also copy this link. Yeah, so when you open this link, you will see that we have a notebook, and which you can open in Colab. Just click on this icon. Yeah, and from here you can follow along. Obviously, there are certain steps which take a lot of time to execute, so I won't be running it throughout. I'll just show that it's running, and maybe you can do it at your own pace. One thing that you need to check is whether the runtime type is GPU or not. So just make sure that it's GPU. Yeah, so I guess till here everyone is set. Then we can start. So basically, there are 4 broad topics that we'll cover in this tutorial. Right, just let me, let me at least. Yeah, so first section is on the demo. So we'll show how the IndicWav2Vec Hindi checkpoint can be directly imported into any notebook and can be run with just a couple of lines of code. You don't have to load any model, download any model or anything from anywhere. We'll just do it through Hugging Face. It's I'm assuming that people here are familiar with Hugging Face. So we'll show how we can quickly set up Hugging Face and load up the models. Yeah, I already have a running notebook, so I will connect to that. So first we'll go through the installation and setup. There are certain Ubuntu packages that we need to install. We'll install Python packages. Then we'll import those packages. So these are the packages that we need. We can see that Hugging Face Transformers library we are primarily using. We are loading the models and processors from there. Torch Audio for loading audio data sets, loading audio samples. Torch is the framework. Then we have data sets from where we load samples also. And there are some other utility packages. And then we have some helper functions. This is basically to load audio from file. Then we will load a sample. Yeah. So here you can see that we go to this directory, which we have already cloned in our setup. The target sample rate, so this is the sample rate of the audio, what we want, because our model has been trained on 16,000 Hz. So that's the target sample rate that will be used for resampling. This is the sample audio path. Let's try running this. Okay. Let's try loading this audio data and resampling it. And let's display it. Yeah. So yeah, you can play it. Yeah. You can play this and see for yourself. Then we'll run the inference part. We have specified the model ID here. This model ID is loaded into Hugging Face, and this device ID is specified, and the decoder type is specified. We are keeping greedy as a decoder type, but this model that we have uploaded to Hugging Face also has LM support. Although the LM that is uploaded on the along with this model is a 3 gram LM, very small LM. We just set it up for the dummy for this demo. Yeah, so we have set it at greedy. We'll now load the models. Yeah, and then we will do. Yeah, here we did a forward pass. So first, let me just go through it again. This is the model instance that we defined, and this is the processor. These are the two things that we need to run forward pass using Hugging Face library. Then we provided the input tensor, the resampled audio, and we run this forward pass and get the logits as output. So when we do greedy decoding, as you can see, we have options for both. If you play it, you'll find that this is almost 100% accurate, or I think it's 100% accurate. So here we see that even this greedy decoding model is giving 100% accuracy. This might not be always. We have an option of LM decoding, which again, as we discussed, which adds this LM into the pipeline. Now what we can do is, again, we can just write from this Hugging Face models, we can directly deploy it as an app, web app. So the first thing is we create a Hugging Face pipeline, which is very simple way of defining our speech recognition model, the model instance, the tokenizer type, the feature extractor, and decoder if there are any, and the device. Yeah, and this is a helper function again for creating this Gradio app. I will not go into the detail of this. It's a very simple function to just create and launch that. Yeah, so the app is up and ready. So I will share this app link as well on the on the Zoom chat for people to try, or you can deploy it yourself and you'll be able to try it. Yeah, so basically what we saw here was that once you have a model trained of IndicWav2Vec style and exported to Hugging Face, it's just a matter of few lines without providing any extra any models or anything. We can directly deploy it as an app. And if you just check the performance in real time, you'll also see that the outputs are pretty accurate. Not 100% accurate, but yeah, it's good. So now what we'll do in the next 3 sections, I'll go back to our table of contents. So in the next 3 sections, what we'll do is fine-tune ASR model using a checkpoint. That could be an English checkpoint, that could be a Hindi checkpoint, whatever checkpoint is there, we'll fine-tune on our custom data. Then we'll train a language model and use it along with our fine-tuned ASR model and check how much is the performance improving. And finally, we'll do this deployment. Again, last part is optional, just to show that you can actually do this one part entirely all on yourself. You can train a model, add language, train an acoustic model, add language model to it, and deploy it using Gradio on Hugging Face. Yeah, so coming to part 2, there are quite a bit installation here as well. So right from part 2, we'll stick to FairSec library, which is the library from Facebook where original Web2Vec was released. We use FairSec for our fine-tuning purpose. So we are setting up this library. We are installing some dependencies. We are cloning our library IndicWav2Vec, FairSec, the KNLM library, which will be used for language modeling, and Flashlight we will use for beam search decoding. There are certain Python package requirements which you can install. And then we'll build a FairSec. So again, it's important that you build with using a particular commit ID, because FairSec keeps evolving and there are a lot of breaking changes. That's why we kept this commit ID. Yeah, so I will not rerun this. This generally takes a while. Then next we build KNLM. And then we build the flashlight. But I think I have removed. Yeah, anyways, I'll run it. I'll keep it running. Okay, yeah. Hopefully this should run. Yeah, but yeah, I mean, I've done a check of this and this was running. Let's move on to the let's move on to the data part, data preparation. So as you can see in the repo itself, you will see that we have sampled some dummy data uploaded so that we can, without downloading any data set, you can actually train on this data. So we have some 1 hour of news on air training data, and you can see that inside the audio there is 2 folders, training and valid. So both contains just the audio files, and we have a manifest folder where we specify the path to those audio files, the transcription of it in the form of letter and word files, and we have this for train and valid. So this is very standard FairSec way of creating manifest. So yeah, I mean, for details, you can either look through our repository where we have detailed documentation on this manifest, or you can look through the FairSec repository as well. Yeah, so once we have downloaded, built all the libraries, you can actually start. Yeah, and we need, so right now what we are trying to show is fine tuning using an existing checkpoint. So we'll download these checkpoints and we'll download these checkpoints and we can actually start fine tuning it. This is the fine tuning command. This is the FairSec fine tuning command. And things to notice here is we are providing the checkpoints that we downloaded. This is the pre-training checkpoint, and we are restoring from a fine-tuned checkpoint. We are providing the data path here. We are providing, this is the max tokens for creating the batch, log interval, the fine-tuning updates, how frequently you want it to. No, sorry, this is the freeze fine-tune updates, which is for 1,000 steps. We freeze the model and just train the final layer. Then there are optimization related parameters. So there are other parameters as well, which you can find in the config file, and more details in the FairSec repository itself. Yeah, but if you just go ahead and run it, you'll find that you're able to actually start running it, and this will actually start training the model. Yeah, so I'm not running this script as of now, but I think that if you run it, it will not throw any error. There is one thing to note that I have also added. There is an option of adding WANDB logging to this FairSec training itself. You just have to have a WANDB account and enable WANDB logging. So these are some of the sample script to do it. For inference, again, it's very straightforward. This time we are doing inference using FairSec. So whatever model we just trained, we'll just we'll provide the path to those models, and we load the modules for decoding, specifically Viterbi decoding and KNLM decoding. So this is using Flashlight library, which we just talked about in our last presentation. Earlier, this Hugging Face doesn't have support for Flashlight, so Hugging Face used PyCTC decode library, but the language model that we train is actually can be used with either of the two libraries. Yeah, so then we load the model, and these are the same helper functions from above, and we can run inference. Yeah, so this is again similar. I won't go into details of each line, but basically we are doing a forward path this time using a PairSec model, and we are generating this hypothesis. And we generate the final greedy output. So the output here is gibberish because we just trained it for a couple of steps only. But if you continue training it for more number of steps, you will actually start seeing good outputs. Yeah, so coming to the third section, which is improving performance using language model. Now, again, as we talked in the presentation, in this section, we'll try to train a language model from scratch using a text corpus, and we'll integrate it with our ASR model and check the results. So we'll start by installing and setting up the repo. Yeah, we are using, again, KNLM for training language model. There are some scripts for cleaning our text corpus, basically just removing foreign sentences with foreign characters and other things. It is very verbose. I won't be going into the detail of this script. So yeah, I mean, yeah, you can prepare data.py. If you go to the repo, you can see that basically what it does is removing sentences with foreign characters, doing num2 word, and certain basic pre-processing that we generally do. So you run this script. By the way, you can see that we need two things for training KNLM. One is obviously the corpus, which we have here. And this corpus is a sentence splitted text file. The first 10 sentences are shown here. And we also need a dictionary. So dictionary is a character dictionary. And again, we are showing the first 10 items. So this is the same character dictionary which we use for training our ASR model. It's important to actually keep the character dictionary same for both ASR and language model. Otherwise, it actually gets into a lot of complexity. So this is the same character dictionary, and as part of preparing data, we'll convert this character dictionary also in the format which KNLM wants. Yeah, so more details can be found in the repo, and you can specifically look at this file. Then we'll actually start training. And as we discussed in our presentation, this is again attaching the training file here itself. There are 3 steps to it. One is creating this ARPA file, which is actually a text file containing unigram, bigram, trigram probabilities. Then we'll filter it using our lexicon. And finally, we quantize and build a binary file. So these are the steps that you can find in our repo, in this file in our repo. The parameters, again, we discussed these parameters in our presentation. This is the n-gram that we want. This is used for pruning, which is, again, it's described in much detail on the KNLM web page, and we discussed it briefly also. And these are the parameters for quantization. Yeah, so running inference, again, we will use the same ASR model that we trained above, and we'll just use this time with the LM decoder. We'll load the LM decoder and run it using this newly trained language model. So as you can see here, we just passed the top K lexicon file and the binary file. Both these files will be created by the this Python script train.kernelm.py. Then, as we discussed also, that there are these hyperparameters associated with language models. Beam is, there are three very important parameters. One is this beam size, which we have kept at 64, LM weight, and word score. So this is basically alpha and beta that we discussed in the presentation. Yeah, so these parameters can be tuned. Actually, we can run a grid search or a random search to find the best hyperparameters. The only thing to keep in mind is that we don't touch our test set. We do this on a validation test set, because actually a lot of information leaks through it, and you'll find that it performs quite well on the validation. It easily overfits the validation set also. Yeah, so this is again part 4 of it. So this will in deploying models, where we'll convert this fair-sec checkpoint to a Hugging Face checkpoint. We'll also convert the language models into the required format, and we'll push it to the repo, Hugging Face repo. Yeah, so again, the installation, we have to log into Hugging Face CLI. You need to have an account for that. And yeah, so we start with initializing the repo and saving a config.json file, which can be obtained from a similar architecture in Hugging Face. So since we are using a Web2Vec2 large architecture, we have specified this already available model to save the config.json. And then we have two things. One is converting to Hugging Face format without the language model, and the other is along with language model. So again, you can find this script in the in the repo itself at this path, and it's doing simple things only. It's taking the PyTorch checkpoint and changing the key's name. So it's just converting it to the compatible format. Yeah, and similarly for adding both ASR and LM, you have to also provide the alpha and beta path, because this also gets fixed along with it. And finally, these will actually push it to the Hugging Face model hub, from where you can deploy it as a Gradio app. Not going into details of this Gradio app, but it's very simple. It's very simple to deploy application in Hugging Face using Gradio. Yeah, and after you run this, you will actually find that from where we started, right at the start of the demo, you will be able to actually generate this app. Yeah, so yeah, I'm almost done. Yeah. Yeah. So so once you have deployed it, you can actually see it, you can run it, and you can check the performance of it. So yeah, so basically we have covered everything regarding fine tuning and language model training and exporting it to Hugging Face format. Yeah, I guess this is what we wanted to cover in today's tutorial. If you have any questions regarding this, please post it on Thank you everyone for joining.